this lesson we are going to learn about conditional probability. When you take a look at conditional probability, the notation looks a little bit weird right away if you haven't seen it before, but all this is saying is it's read as the probability of E2 happening given that E1 has happened. So this means you choose E2 out of only E1, not the entire group. I don't know if that makes a lot of sense until you actually see an example, so we'll just start with that. Remember, we're talking about cards a lot this chapter, so here's a single card is chosen from a standard deck. So here we're saying the probability of us getting a heart given that we're only dealing with aces. So given that we're only dealing with aces, how many total aces are there in a deck? There's 4. So this isn't out of the whole deck. Given that you only have aces, what's the probability of pulling out a heart? So of those 4 aces, there'd be 1 from each suit, right? Excuse me. So hearts, diamonds, clubs, that's a really bad club, and spades. So since there's 4 choices there, the probability there'd be a heart, that one of those is a heart out of the 4. So that's considered a conditional probability. The word conditional, if you want to think of it, your parents give you a lot of conditions, and that's one of the ways you can think of it as. You probably hear a lot of, yeah, you can go to the movie Friday night if you clean your room, if you take your brother to practice for me. Whatever that would be, those are conditions. So this is what these are examples of in math, is they give you a condition first, and then you have to decide what it's going to be after that. So B says the probability it's an ace given that it's black. So we have 26 black cards. How many of those black cards, so just from the black cards, how many of those are aces? Well, the ace of clubs and the ace of spades. So we'd have 2 of those. So we'd say our probability is 2/26, which we would then reduce to 1/13. So given that we only have black cards in the hat, what's the probability we would draw an ace? Then C says, given that a diamond is chosen. So given that a diamond is chosen, what's the probability of getting a 2? So there are 13 diamonds. How many diamonds are the number 2? Just 1, right? So our probability that would be 1/13. Hopefully that makes sense to you for those conditionals there. In number 2 it says in a family of 2 children, and then they're going to have different probabilities. So we're going to do a tree diagram. I'm just going to move this down so we can see our problems, and I'll do my tree diagram here. When I have children, I can have a boy first or a girl first. And then your second born child can be a boy or a girl, and still a boy or a girl. So there is my tree diagram. If I want to do my sample space, I'd list them here. So those are all of the options for what you could have for children, and birth order here if you had 2 children. So what's my probability of having 2 girls? Since only one of them is 2 girls, you'll see that that's 1/4. That's one we've talked about before. Here now is a conditional one. What's the probability of having 2 girls given that the older child is a girl? Well, I'm only looking here then. I don't look at the other 2. Given that the first one's a girl, so my firstborn child's a girl, what's the probability that I'd have 2 girls? Well, there's only one that's 2 girls out of the 2 choices, so my probability is 1/2. And then C says probability of having 2 girls given that there is at least 1 girl. So if there's at least 1 girl, that's these 3 right here. So I have 3 possible choices, so I'm going to say my bottom number is a 3. And of those 3 choices, how many say that I'm going to have 2 girls? Just 1. So you have a 1/3 chance of having 2 girls given that there is at least 1 girl. Okay, so there's some more conditionals for that. As we go to the back, this is actually more of where you'd see conditional probability coming in, is in these tables. And if you're taking AP Stats, this is actually something we work with quite a bit, conditional probability. And it says, this is the chart for people who like Chinese food, and they happen to divide this data into people who like Chinese food and then also by age. So maybe they thought when they were doing this study that there'd be a difference in age on who likes Chinese food and who doesn't. Which kind of makes sense, because think about Chinese food has a lot of vegetables in it, and kids tend to not like vegetables as much as you do when you're an adult. You maybe like a little more spice or variety in your meals. So to start, they're not doing a conditional one. They're just saying the probability that someone likes Chinese food. So for that, we're going to just go to the how many people like Chinese food, 306, and they surveyed a total of 500 people. So we would say our probability for that is 306 people out of the 500 surveyed like Chinese food. Or if we reduce that fraction, There would be our answer. So the conditional part comes in here, where it says probability that you like Chinese food given that you are 12 and under. So we are only looking at 12 and under. That's this right here. This row in our matrix. And that's what this would be called as a matrix when you see this data form like this. We're only looking at the 12 and under group. So of the people that are 12 and under, how many like Chinese food? So there are 103 total 12 and under kids. So that's going to be our denominator. And then how many of those 103 said they liked Chinese food? 21. That number came from right here. So I didn't look at any other category for age, like the over 12, for example. I just looked at the 12 and under. I got a 21 out of 103. So that's how many of the 12 and under people like Chinese food. Then it says the probability that the person is over 12 given that the person doesn't like Chinese food. So here, the person is over 12 given that the person doesn't like Chinese food. So all we're looking at here is the don't like Chinese food category. That's what they told us. So what they say last is what you think of that. Given that the person doesn't like Chinese food, so there's our given, that column right there. What's the probability that the person is over 12? So this is how many people are over 12. So it'd be 112 over the total number of people that don't like Chinese food, which is 194. So when I reduce that probability, I get 56/97. So make sure that when you're looking at these, the part that's given, that's the column or row you're looking at. You don't look at the whole table for when they give you a conditional probability here. You look at just what you're given. Last few here then, it says you roll 2 dice. What's the probability that at least 1, 3, given that the sum is 7? So we're going to have to come up with all the ways that we could get a sum of 7 rolling 2 dice. So we don't have a 0 with dice, right? Here's the numbers we have. So we could get 1 and 6, or 6 and 1, right? Because it can go either way for the first and second dice. 2 and 5 make 7, or 5 and 2, and then 3 and 4, or 4 and 3. Those are all the different combinations I could have rolling 2 die, where I would get the sum of the die to add up to a 7. So that's considered my sample space. So given my sum of 7, here I have, let's see, 6 choices total, right? So given that I'm going to use one of these 6, what's the probability I get at least 1, 3? So the number 3 is what they're talking about. So there's 2 of them right here. So I would say that is a 2 out of 6 chance, which I would reduce to 1/3. So there's a 1/3 chance. So first I had to figure out what they had given me, and that was something they didn't tell me. I had to figure that out myself. And then I pull from that sample space to decide what I'm going to pick for my probability. Number 5, it says a class of 40 students has 11 honor students and 13 athletes. 3 of the honor students are also athletes. 1 student is chosen at random. Find the probability the student is an athlete if it is known the student is not an honor student. That's a mouthful, right? So what we're going to do here is actually draw a Venn diagram. And I don't know how much you've used these before. This is the geometry thing. But we have 40 total kids. And then we have athletes and honor students. So I'm going to say this one is my honor students, just because they listed that first, and this one is my athletes. Now notice I connected those circles because they did tell me that I have 3 of the honor students that are also athletes. Let me pick a different color here. 3 honor students are athletes. So I'm going to put the 3 right in the middle here. Those are the kids that are honor students and athletes. And then I'm told I have 11 honor students total and 13 athletes. But I don't want to count those 3 in there. So since I take out the 3 that I put in the middle, I really have 8 just honor students. And I really have 10 just athletes. And then I have 3 that are both. That's really what they give me for information. So I'm going to put an 8 here and a 10 here. On the outside of your circles, that is how many other kids there are. So when you add these numbers up, you get 24. Just kidding. How about 21? I can't add for some reason. So when I add these numbers up, I'm going to get 21. So I take 40 minus 21, and this is my number of kids that are not honor or athlete. So those are the kids outside the circles. So now I'm going to actually see what they're asking me about. So what I do first is draw this picture so I can get I just kind of can see a visual of what they're talking about. And then I'm going to look at what they're asking me. So it says, find the probability that this student is so one student's drawn at random, find the probability this student is an athlete if it is known that the student is not an honor student. So, an athlete, but it's known that the student is not an honor student. So these two don't get counted at all. So the students that are not honor students are the athletes that aren't honor students plus these 19 kids. So I have a total of 29 kids of the 40 that are not honor students. What's the probability this student I draw at random is an athlete? Well, there are 10 athletes. So I have a 10 out of 29 chance. And again, I didn't count the honor students because of the term where it said given that, if it is known that the student is not an honor student. So those people did not get counted in my total because they told me that that was my condition. The last one. 2 cards are drawn in succession without replacement from a standard deck of 52 cards. Find the probability that the second card is a diamond if it is known that the first card was a diamond. So this kind of goes back to what we learned with our and/or probabilities. If the first card's a diamond, my probability of drawing a diamond is 13 out of 52, right? Because I have 13 of each suit and there's 52 total cards. And then to find the probability that my next card, or my total probability if I want to, the next card then that I draw, my second card, since the first one was a diamond and I'm not replacing it, I have 12 diamonds left in my deck out of 51 cards. The trick here is, though, they didn't ask for the probability of having this happen where I draw 2 diamonds. They said find the probability that the second card is a diamond if we know the first card is a diamond. This is us knowing the first card is a diamond. So this is my probability of drawing a diamond the second time. I'm just looking at the second card. So my answer is actually the 12 out of 51. Sometimes these can be super easy for you or they're a little bit tricky, so make sure if you have any questions on that you ask me, and you will have a worksheet for this tomorrow and an objective.